Welcome to another junior algebra video. We're going to chat about adding and subtracting like and unlike terms. Now, the key thing here, we can only add like terms with like terms. And we'll explain this as we get into the examples. So, example 1, simplify 2x plus 3x. Well, we have an x, 2 times x, and we have a p, 3 times p. They are unlike terms. They're different letters, different variables. And so unfortunately, we can't add them in this example. So I can't do anything with this expression. So let's move on to example 2. Simplify 2x plus 3p plus 4x. Well, in this example, I have x and p's, but I also have 2x and a 4x. So the 2x and the 4x are like terms, and I can add those bits together. Now, notice I've got a plus 4x. So I'm going to go 2x plus 4x makes 6x. And I'm left with this plus 3p. I can't add that with the x because they are unlike. So I'm just going to write plus 3p at the end. So my final answer is going to be 6x plus 3p. I've added the 2x and the 4x because they're like, but I can't add the 3p. Now, be careful in algebra when you go something like 6 plus 2 is 8. It doesn't matter if you go 6 plus 2 is 8 or 2 plus 6 is 8. It doesn't matter which way we add things. So if you wrote 6x plus 3p, you could also write it as 3p plus 6x. Doesn't matter when you add things which way around. All right, let's move on to example 3. Let's simplify this expression. 5x plus 6p plus 2x plus 3p. Now notice we've got some like terms with the x. So we've got a 5x plus a 2x. That gives me 7x's. And notice we've also got some like terms with my p's. So we have this plus 6p plus the 3p. So we've got a positive 6 plus positive 3. That makes positive 9. So we're going to write down plus 9p. We can't add the x's and the p's because they are unlike. So we can't add it any further. So that's our final answer. And again, remember we can write it as 9p plus 7x if we prefer. Right, example 4. Let's simplify this one. 12x, take away 6p, take away 2x plus 10p. So our first set of like terms are these x's, 12x minus 2x. Now notice the 2x, I've looked on the left and it's a minus 2x. So I've got to go 12x minus 2x gives me 10x. 12 minus 2 is 10. So that's my first set of like terms. Here's another set of like terms. Minus 6p plus 10p. My p's are like. So I'm going to go minus 6 plus 10. Minus 6 plus 10 makes positive 4. Think of your integer skills. Minus 6 plus 10 makes positive 4. So I'm going to write down plus 4p. Now again, I can't do anything with my x's and my p's. So I can't simplify it any further. So I've got 10x plus 4p is my final answer. Or if you prefer, 4p plus 10x. When you add things, it doesn't matter which way around you add them. All right, our final example is this one here. It's a little tricky, but let's talk about this. We have a lot of e's, but in the first term, we have an e squared, and in the second term, we just have a 3e, just an e by itself. And I need you to understand that e squared is different to an e. They are unlike terms. Even though they've got the same letter, one's got a power of 2 and one doesn't. So e squared and e are unlike, and I can't add these two together. But I can add these two because they've both got e squareds. So I've got 6e squared minus 2e squared. That leaves me with 4e squareds. And then I've got this plus 3e, which I'm just going to write down here, and I can't add those together. So I'm left with 4e squared plus 3e, or 3e plus 4e squared. Right, thanks for watching.